All right, ladies and gentlemen, so we are going to continue along our journey with proportional relationships. So last week, when we finished on Friday, we looked at example number one, and then we did the triad. Now today, and we talked about proportional relationships, okay? Now, when we looked at proportional relationships, does anyone remember what had to be true about a proportional relationship? I heard some different things.
Equivalent ratio.
Very good. So, for a relationship to be proportional, all ratios need to be equivalent. Okay, so what does that actually mean? That means when I reduce down my ratios, they all have to be equal to each other. So we did we did two examples on Friday. We did this example here that talked about the ratio of gold coins to lives. And we figured out for every one gold coin you get, you earn 3 lives. Each one of these had a ratio of 1 to 3. So that means that this relationship was proportional. We also did this, which was file size to download time. And we reduced all of these ratios to 20 over 1. Because they all reduced to 20 over 1, we knew this relationship that was proportional. So it didn't matter, and it doesn't matter how large the file size is, it's always going to take 20 seconds to download 1 megabyte. So today what we're going to explore is we're going to explore when we see relationships and how to determine if they're proportional, if they're not proportional. So we know that a proportional relationship, all ratios need to be equivalent. What do you think a non-proportional relationship looks like? Tucker?
The ratios are equivalent.
Very good. So in a non-proportional relationship, I call it non-proportional. Some people call it not proportional. Does it matter? So one or more ratio is not equivalent. Okay? So a non-proportional relationship, one or more ratio is not equivalent. So when we're thinking about this in these relationships, we need to look at every single relationship, and we need to test every single relationship to determine whether or not they're proportional. We might test the first 2 and those 2 are proportional, but then maybe the third one is not, and we've shown that it's not, and we thought it was proportional, actually it's not proportional. So we need to test every single relationship when we're given these ratios. So again, proportional relationship, all ratios need to be equivalent. Non-proportional relationship, one or more ratio is not equivalent. So here's an example. And again, what page is this, 99? Yep. Okay. So we're on page 99. So in page 99, we see this relationship. And they're asking, is the relationship between the area and the side length of the squares proportional? So we have 3 different squares. 2 inches by 2 inches, 3 inches by 3 inches, and 4 inches by 4 inches. Now, when we find area, we always multiply the length times the width. Okay? Or if it's a square, we do side squared. Side times side. So we have a 2-inch square. So the side length is going to be your independent variable. Your area is going to be your dependent variable. Your area depends on your side length. So again, our relationship is y over x. Okay? Every proportional relationship we write as y over x. Dependent is in the numerator, independent is in the denominator. So if we have our side length of 2, 2 times 2 is 4.
Could Mr. Spears be forward to the office, please? Mr. Spears, thank you.
So our side length is 2. 2 times 2 is 4. So then our ratio is 4 over 2. So when we divide 4 over 2, we get 2 over 1 as our ratio. So that means for every 1 inch of side length, there's 2 inches of area. Now if you've got a 3 by 3 square, 3 times 3 is 9. So our ratio is 9 over 3. When we reduce 9 over 3, we get 3 over 1. What do you notice about this one and this one? They're not equivalent. So is this a proportional relationship? No. This relationship is not proportional because all of our ratios are not equivalent. You can test the first two. If the first two are not equal, what do you think you could do?
Just
Move on. It's not proportional. Okay? The only explanation that you need to give is the ratios are not equivalent, therefore it's not proportional. Okay? So you can go even further. A 4-inch square, 4 times 4 is 16. 16 divided by 4 is 4 over 1. 2 over 1, 3 over 1, 4 over 1. Proportional?
no.
No, because they're not all equivalent. So the ratios are not equivalent, so the relationship between the area and the side length is not proportional. Yes, sir?
So does it matter if, say, the first and third one are equal, but the second one is not? Is it still not proportional?
It's still not proportional.
They're all-
So what Zach just asked, does it matter? What if this one and this one are both 2 over 1, but this one's not? Okay. So our definition says 1 or more. So as long as there's one that's not proportional, the whole relationship is not proportional. Good question. Excellent. All right. So let's look at this one. This is our try it. Oops. The table at the right shows information about regular hexagons. How many sides is a hexagon?
6. Octagon has 8.
Octagon has 8.
Hexagon has 6. No, that's a 6.
Triangle has.
3.
Quadrilateral has.
4.
Pentagon has 5. Oh, sorry. Pentagon.
5.
Hexagon.
6.
Septagon.
7.
Septagon is 7. Octagon.
8.
Nonagon.
9.
Decagon.
10.
There you go. Okay. So hexagon. So a hexagon has 6 sides. Okay. Penta, hexa, septa, octa. Okay. So penta's 5. Hexa's 6. Septa's 7. Octa's 8. So this is a 6-sided figure. Is the relationship between the perimeter and the side length of a hexagon proportional? Perimeter, how do you find perimeter of any object? We add up the sides, right? So, how many sides does a hexagon have?
6.
So, if we're going to find the perimeter of a hexagon,
You have to add up.
can we do 6 times x?
Yeah.
Right? Because 6 times the side length
It would give you
is going to give us the perimeter, right? So if we have a perimeter of 2, 2 plus 2 plus 2 plus 2 plus 2 plus 2 is 12. So 6 times 2 is 12. So then the side length, if we've got 3, is 3, 6, 9, 12, 15, 18.
So they're both
So when we're trying to figure out if a relationship is proportional, what do we use? Do you remember? Something over something. We use a fraction,
X over Y.
not x over y.
Y over X.
Y over x. It's always y over x. I would be writing this stuff down, guys. Okay? Actively engaged. So to find if a relationship is proportional, we always use y over x. Okay? Now if it's y over x and if they all reduce down to the same value, then we have a proportional relationship. Okay? So in this case, our perimeter is our dependent variable, our x is our independent variable, which is our side length. Because our perimeter depends on the side length, right? So our perimeter for the first one is 12
Over
over 2.
which, yeah.
Okay? What do 12 and 2 have in common?
They're both divisible by 2.
Both divisible by 2.
So it'll be 6 over 1.
So 12 divided by 2 is 6.
Then
2 divided by 2 is 1. So our ratio is
6 over
6 over 1. So that means for every 1 inch of side length, our perimeter is going to be, we have 6 inches of perimeter. So the second one, what's our ratio for a hexagon that has a side length of 3? So what is our ratio?
no, 18 over 3.
18 over 3, because we do y over x. What do 18 and 3 have in common?
They're both divisible by
By
3.
Okay, 6 is like the missing factor, because 18 divided by 6 would give you 3. Okay, so their common factor though is 3. So I divide both by 3. So 18 divided by 3 is 6, and then 3 divided by 3 is.
1 less than. So they are proportional.
Is this relationship proportional?
Yes.
Okay. Well, honey,
Is what you're dividing by always the denominator?
sometimes, not always.
Yeah, because you have to figure out what they are in common.
If you're trying to find your unit rate, always. Yeah. Okay. What if I had a 4-sided figure?
It would be 24.
Okay. 4, 8, 12, 16, 20, 24. Okay. Are we still proportional?
Yep.
Yes. Then you just divide by 4. So it'll be the same thing.
24 and 4 have a common factor of?
6.
So 24 divided by 4 is 6. 4 divided by 4 is 1. Okay. What about
60. Yeah.
30?
No.
30. Wait, no, 10. Wait a minute.
Wait.
You're right, it would be 60.
Yeah.
Because
Well,
depends on what it is.
Yeah,
Because
it's
it would be
40?
60 over 10.
It's a hexagon, guys. We're still working with hexagons. It's right here. Okay. 10, 20, 30, 40, 50, 60. Okay, so our ratio would be
60 over 10. And it could both be
Divide by
divisible.
10.
They're both divisible by 10.
We did like 100.
is this relationship proportional?
Yes.
Yes, because we have. Okay, so yeah, this relationship is proportional. It's proportional because all of the ratios are equivalent. Right?
If we did a million.
What?
So what if we did a million? That's still even proportional.
No, because we have our equation of 6 times x. So 6 times a million would be 6 million. And then 6 million and a million have a common factor of 1 million, so wouldn't take you forever. So this relationship is proportional because all ratios are equivalent. That's your explanation. I don't know what I can. You guys, I'm gonna just be very honest with you. If I were you, I would have this stuff written down if you haven't written it down. Okay? Because like I just walked around and I saw quite a few people that didn't have anything written down. So just make sure you're writing this stuff down so you have a record of what we're talking about, right? And your reasoning behind it. Okay? So we know proportional relationships all have equivalent ratios. So if what is our explanation? If someone or somewhere were to ask you to explain why this is proportional, you know exactly what to write, correct? And you know why that's proportional. Relationship. Is that better? Relationship. Relationship. Making up my own words. Mosaic Dictionary. Okay. So now, oh, that's fun. Example number 3. A proportion is an equation that represents equal ratios. Use the table at the right. How many times will a hummingbird beat its wings in 60 seconds? Okay, so a proportion is an equation that represents equal ratios. Okay? So equal ratios. So if I have 1/2 and 5/10, those two ratios are said to be in a proportion with each other because they're equivalent. So these ratios are equivalent. They're in a proportional relationship. An easy way to test for proportionality is called cross products. So cross products, diagonal products are equal. So when I say diagonal products, numerator times denominator, numerator times denominator. So 2 times 5 is 10. 1 times 10. So diagonal products are equivalent. Okay, so that's how we test for proportionality. Okay, that's a really, really easy way and quick way to determine if two ratios are in proportion with each other. Okay, so diagonal products are equivalent or equal. Okay, now this can help us. So right here, we've got 2 over 160, 7 over 7, I'm sorry. In 2 seconds, the wings beat 160, 7 seconds, 560, 10 seconds, 800. Okay? So what I can actually do is I can create a ratio. 160 over 2. The number of wing beats that we count depends on how long we're counting. So 160
There's 2 seconds.
over 2, right? How many seconds do we want to know about? 60. Okay. If we don't know something, what can we do?
Divide.
Okay, we can divide, but if we don't know something, what do we put in the place of something that we don't know?
A variable.
A variable. So we want to know about 60 seconds. We don't know how many wing beats that would be, correct? Okay. If we do diagonal products, 2 times x is what?
2x.
60 times 160.
Is 6,400.
Oh, get on your calculators. Like, let's go, guys. Come on. Personal invites here. Huh?
9,600.
Do you know how to solve this? What are you going to divide by?
4,800.
$4,800?
Yeah.
So what does 4,800 mean?
That's how many beats there are in 60 seconds.
That's how many beats there are in 60 seconds. Is there another way we could do this problem? Yes, okay.
Yeah.
Zach, what do you think?
Well, you can look at 800 beats per 10 seconds and divide it and say that's 8, and then 8 times whatever 60 is, and then put that on the
Okay. So what Zach said, okay, so what Zach says is basically find a unit rate, right? Okay, so Zach wants to take this and get to 1 beat. Okay, how do I get from 10 to 1?
Divide by 10.
Okay, so if I divide 10 by 10,
Just divide by 8.
okay, which would be 80. Okay, now, but I want 1 second, I want,
60.
how do I get from 1 to 60?
Divide by 6. That's a lot easier.
I feel like the easiest way would be to
Right.
divide 6 and then.
Okay, so are there different ways to do the problem? Yeah, absolutely. Now, this method here, yeah, this method works. Awesome. Right? Absolutely it works. Okay? Our problem becomes when our numbers aren't so clean. Okay? When our numbers aren't so clean, then this cross products method is a really good way to go as well. Okay? So, testing proportionality, cross products is an awesome, awesome way. Okay? Numerator, denominator, numerator, denominator, as long as they're equal, the relationship's proportional. Okay? This here is a good way to find x if your numbers aren't as clean. Okay? What, honey?
Says they not take a shower.
Do they not take a shower? Yeah, I guess we could say that. All right. Here we go. This is our try it. Ginny's favorite cookie recipe requires 1.5 cups of sugar to make 24 cookies. How much sugar does Ginny need to make 36 of these cookies? Are we doubling the recipe?
No. Yes.
No.
You're dividing it
Okay.
in half.
So, what do you want to do?
Find the unit rate.
Okay, we could find a unit rate.
Sorry.
Okay. Now, so you want to make one cookie? We want to figure out how much it takes to make one cookie?
I would
Okay.
have made it see how much is 24.
Well, wait a minute. Hold on. Just wait. Let's get a bunch of. Just wait. Just wait. Okay. We have an idea from our classmates. So what are we gonna do?
Listen to it.
We're gonna go with that idea, right? Okay. So Bob wants to find a unit rate. I'm with that.
I'm down. Oh yeah. I'm down.
Okay. Good.
Yes.
Okay. Now, how much sugar then, or how would I figure out how much one cookie needs? What do I have to do?
160.
Okay, we divide, right? So I divide top and bottom by what?
124.
So 24 divided by 24 gets us to 1. So then 1 and 1/2. My baby comes out smush, it's your fault. All right. Sorry. All right, so 1.5 cups divided by 24. 1/16 of a cup. I don't want one cookie. How many cookies do I want? 36. How do I get from one cookie?
Multiply.
Okay.
And you. 214. 214.
That's what I had.
Is that 116?
That's 9, 4, 2, 1.
So 2.25 cup of sugar to make 36 cookies. Okay. So Bob said go down to the unit rate, go back up to 36. Excellent idea, right? Okay. So that's one method. Okay. What's another one?
Turn it into an improper fraction.
Okay. And what are you gonna do with that?
I would make it into 2 fourths and then make it into 6 fourths, divide it, make it 3 fourths, and since that's for 12 cookies, just multiply by 3.
Okay, so you want to get down to 12 cookies and then go back up to 24 cookies, or up to 36 cookies?
Yeah. And 12 cookies equals 3 fourths. 3 fourths times 3 fourths times 3 equals 2 and a fourth. I'm sorry.
So you want to go down to 12 cookies
Yep.
and then go back up to
36.
Okay, so we got to divide by 2 here.
Yep.
And then divide by 2 here. Okay, so that's 2 fourths, and that's 4 fourths.
6 fourths divided by 2 equals 3 fourths times 3 equals 2.
Okay. So can I ask you a question? So did we really do anything different
No.
between this method and this method? No, this one we got down to a dozen and then went back up to 3 dozen, right? which is basically what we did. I mean, you can go back to, we could change 24 into 2 dozen, which is exactly the same thing we're doing here. Okay? Anyone have any other ideas?
Probably is.
Any other ideas? Do you want to see my idea? Okay. My idea is cross products. Like, and so here's a thing to know about me. I love a proportion. I love to set up a proportion. I love to solve a proportion. You can give me pretty much any math problem, and I set it up as a proportion to solve it. I don't know what it is. I'm a proportion girl. My best friend Monica sets everything up as an equation. We get the same exact answer. She loves equations. I love proportions. Doesn't matter how you set up a problem, you can get the same answer, right? So when I set up a proportion, I know 1.5 cups gives me 24 cookies. But I don't want 24. I want 36. I don't know how many cups I need for 36, so I put an X. Okay, so then I use cross products. 24 times X is 24X. Okay. And 36 times 1.5 gives me 54. So now I know that 24 is being multiplied by X, so I divide both by 24. So 54 divided by 24 is 2 1/4. Okay. So it's 2 25/100, or 2 1/4, right? Still the same thing. Okay. Here with Bob, we used unit rate. Here, we got it down to 12, so compatible number. And we were able to then multiply back up. So we scaled down to scale up. Mine was cross products. What do you notice about all the answers? They're all the same. Do I care what method you use? No. Absolutely not. Okay? As long as you get the right answer and you can check it, and you can explain to me why you use the method that you used. Okay? Say I used PhotoMath, or I used. No, I'm not talking to you. I know. I watch you. I sit back there and I watch you. I know. Or I use like whatever math app, or I plug it into the computer, whatever it is. That's not an explanation. Knowing exactly why you used the method that you used, that's what's important to me. So tonight, what I would like for you to do is I want you to do page 101. And I want you to do 7 through 10. Your quiz is going to be on Friday. Okay? So it's 2-1, 2-2, and 2-3. Is it the 19th? No. Yeah. 17, 18, 19?
Yeah.